So thank you, Kid President. Again, find your purpose. Systems that have people in them, living systems, multi-minded sociocultural systems. Everyone needs to have a purpose, and the idea is to make things better. And as Kid President says, give people a reason to dance. Sure, why the heck not? Our next topic is multi-dimensionality. It's sort of straightforward. It sort of is exactly what it suggests that it is. It really is the ability to be multiple things at one time. Have some dimension, to have multiple dimensionality about whatever system you're talking about. I just needed an example, so I just was sitting here, not working out. So I thought I'd think about a fitness club. So unfortunately, during COVID, LA Fitness and others are closed at the moment. But if you did own an LA Fitness, or you joined a health club, maybe the reason that you went, the purpose you went to the health club was for health improvement. You want to feel healthier. Maybe you have a very stressful day, a very stressful career, and going there reduces stress. So a different person could use their health club or fitness club membership as a stress reducer, or the same person could use it for both. Maybe it's just a hobby. Maybe you're into fitness. Maybe it's for socializing. Maybe you happen to have some friends and you've all joined a particular class. Maybe you go to spinning together or Pilates or whatever it happens to be. Maybe you work there. Maybe you work at a fitness club, and perhaps the fitness club in your neighborhood provides a lot of jobs, and so that the reason why, the purpose of the fitness club is to employ people. Maybe you go there for networking. Maybe it turns out that every morning there happens to be an LA Fitness right next to GlaxoSmithKline out here in Collegeville that I was member a while ago, and I'd go there very, very early in the morning before I would drive into LaSalle. And the majority of the people that were there very, very early in the morning happened to work at GlaxoSmithKline. So there was a lot of fellow scientists and a lot of fellow life scientists that worked there. And if you happen to strike up a conversation, hey, where do you work? I work at Glaxo across the street. So maybe it's a learning environment. Maybe you're there to learn about fitness, and maybe it's just for entertainment. Maybe you're in your phase of life, you're just kind of bored, and what should I do early morning, or what should I do after work? The purpose for all of this, again, we're talking about the purpose. Just got done talking about purpose. Sorry about that. Is that the fitness club can be all these things to one person, or they can be all these things to multiple people. But a fitness club, as a system, has multiple purposes and multiple ideas and multiple reasons for existing, and you can make changes that might help all of these things at the same time, or you might make some changes that hurt some or help others. So you have to be mindful that you can't just think of this thing as being one thing. It's multidimensional. So as scientists, we think multidimensional all the time. Typically, we can put a dimension on a particular axis. So I'll just generically label this as an example, the x-axis and the y-axis, generically using the horizontal axis as being x and the vertical axis as being y. And when we talk about a position on this particular x and y axis, there's this little circle right here, obviously it has an x value and a y value at the same time, simultaneously, as I love to say in the previous ISBIT 112 class, our physics class. So this one thing is obviously existing on these two axes at the same time. So where it has the fitness club being 8 or 9 things simultaneously, that's multidimensionality. This is just 2 dimensions, but that's fine. We can draw a 3-dimensional plot. We can draw a 12-dimensional plot. Yes, with computers, we can draw a million-dimensional plot. It depends on how you want to work. So what we're going to do is, when I'm talking about systems, is we're going to sort of name these axes. So yeah, we have the vertical axis and the horizontal axis. Look at the vertical axis, and on this axis, we're going to put a human's ability to find similarities among objects that appear to be different. So in this case, if you walk into a room and there's a whole bunch of things that appear to be different, if you can summarize or you can generalize or you can classify or you can come up with some theory as to how all these things are related, that's what we're talking about on this particular axis. Okay. On this other axis, a different axis, we're talking about the opposite, the complementary ability of humans. In this case, we're looking at the ability to find differences among objects that appear to be similar. So over here we had similarities among objects that appear to be different. Down here we're looking for differences among things that appear to be similar. So it is the complementary dimension, if you will, or the complementary ability, one on the vertical axis and one on the horizontal axis. No surprise here, you probably already guessed it if you went ahead and peeked and looked ahead of the video. The ability to find similarities among objects that appear to be different is what scientists do. So scientists look at a whole bunch of data, they do a whole bunch of tests, and then they sort of crunch the numbers, we use some statistics, and we summarize what the conclusions are. Hey, there's a whole bunch of animals in that field. Well, turns out a majority of them are bunnies. I don't know why I'm on bunnies tonight, but majority of them are bunnies, and oh, by the way, the bunnies happen to have 2 ears and 2 eyes and whiskers and 4 feet. Some bunnies may have longer ears than others. Don't know why I'm thinking this way. Maybe a bunny had an accident, maybe he's missing an eye, I don't know. But generalizing, we can say that bunnies typically come with 2 eyes. So that's a science thing, to be able to summarize and find generalities among a whole bunch of things and not get too distracted from all of the things that appear to be different. And of course, on the other side is the artistic ability. And of course, I keep on mentioning that we, as ISBIT, are in the School of Arts and Sciences. And so we are definitely asking folks to take classes, especially in their ILOs and their core classes, from the arts and the sciences. And the idea is that you would use these different abilities in the arts to find differences among objects that appear to be similar. So say, for instance, I'm at the Philadelphia Art Museum, and I walk into a particular gallery, and there's a whole bunch of paintings on the wall. Now, if I'm in science mode, I might say, "Oh, look, a painting. Look, here's another painting. No, here's another painting." Okay, they're all paintings. They're all oil on canvas. They all happen to have just about all the colors of the rainbow. Most of the paintings happen to be still life. Hooray! Summarize, 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 and that's fabulous. But as an artist, if I were to go ahead and go into art mode, or if I have any art abilities, walk up to a painting, that's when somebody says, "Oh my gosh, look at this perspective. Look at these brush strokes. Look at the colors the artist used. Look what the artist was trying to depict. Look at the shadow. Look at the I mentioned perspective before. All of these things that make this particular painting different from all the other paintings on the wall in the same gallery. That's when you're using your art perspective. So we have the ability to summarize, and we have the ability to find differences. And we use this all the time, not just in an art museum and not just in the lab. This ability is what humans have. Systems have multiple dimensions, and so do humans. Humans have multiple dimensions. In this case, we're talking about the 2 dimensions of thinking scientifically or thinking artistically. So what we're going to do is we're going to go ahead and quantify this. So we're going to put the origin down here. Typically we put 0, 0 as the origin. We're going to have a low ability to do this down in this area. We're going to have a high ability or expert. Then the same thing with art, a low ability to art and a high ability or an expert in art. And of course we're going to draw a quadrant so that if I were to stick some points in this area, it would be low, low. And if I stuck some points up here, it would be high, low. And over here it'd be high, low. And over here it would be high, high. So what we want to do is, now that we've sort of divided this thing up into 4 different areas, we're going to have 4 different abilities that are multi-dimensional that humans can bring to the table. If it's low, okay, so if you're not using your ability, if you're not spending much time to try to summarize, or you're not spending much time to find out what the differences are or differentiate, then you're just sort of imitating or doing what you're supposed to do. And I'm not suggesting that this is machine mode, but I'm going to go ahead and say it. This is machine mode. This is when humans are asked, don't think too hard about it scientifically wise, and don't think too hard about it artistic wise. It'd be great if this machine was a different color. Maybe it would be safer. Maybe it'd be more interesting. That's not what just do your job. Now we're down here in this imitations and doers side of things. So this is where people are acting like machines. Again, they're still people. They haven't been dehumanized. It's just they choose to sort of just fly through their job, sort of on autopilot, if you will. Again, autopilot means they don't need to engage their brain. Maybe they have a kick-ass hobby. Maybe they're going to the fitness club. Maybe they're going to go ahead and join the Olympics. Maybe they're going to be Mr. or Mrs. Universe as far as bodybuilding wise. Maybe they're going to have a UFC fight coming up, and they just go to their day job. They just go through the motions. They get a paycheck, and yeah. I just want to do my job. That's where the imitations and the doers are. But of course, if we happen to have folks who spend time thinking as a scientist all day, typically those are the folks that we consider to be problem solvers. And again, for all of you who happen to join me either this past fall or previous fall in ISBIT 112 when we were doing our problem solving approach, where we drew a picture and then, we read the problem and we read the problem, then we drew a picture, then we wrote down what we wanted to know. We went through this little mantra of hey, every problem can be solved the same way. We generalized all the problems so that if you follow the problem-solving process, you have a really high chance of solving the problem. And of course, that's what scientists do. They find similarities and say, oh, look, another physics problem. Let's solve it exactly the same way. Well, I can't use it exactly. Let's solve it. Solve it using the problem-solving method we used before of read the problem, draw a picture, write down what you want to know, find out what they're asking, find out what equations you're going to use, and go through the entire thing. Folks who spend their day doing that are considered to be problem solvers, and most of those folks are scientists. So now we have the other side. What about this side, where folks are looking for differences all the time? They are the problem formulators. So what they're doing is they're defining the problem. Hey, Bob, we have a problem. Well, it was working yesterday. Well, it's not working today. How do you know it's not working today? Because it's doing this. This is different than was yesterday. Oh, you're right. It's off a little bit. Yeah, that's huge. And this off a little bit might be off a lot of bit tomorrow. And if you're talking about a welding robot and it just goes ahead and welding the seam of a particular joint on a car, if it's slowly out of whack and all of a sudden it's not welding anymore and the car falls apart, that's a bad thing. So it turns out that whereas scientists spend most of their day solving problems, they need to get their problems from somewhere. When scientists are doing science, they're solving problems. They're not finding problems. It is the artists that find problems. And this always gets me in trouble whenever I say this. What about the School of Arts and Sciences? If you go into the arts departments, usually you'll hear them, here we go, I'm going to get in trouble, you're talking about problems with society. Like, hey, let's go ahead and read a book about how badly the 1980s sucked, or how badly World War II sucked. I agree. How badly the Nazis sucked. I totally agree. How bad being a monarchy sucked. Yeah, that's fantastic. A lot of the things that you learn in your humanities and arts classes are about how crappy everything is. Doesn't mean they're not happy. It's just that's their job. Their job is to find problems and let people know about it. The way that a system works, or the way that a society works, an open system works, is that the folks who are finding problems hand them over to the scientists, and the scientists spend time trying to solve them. And then sometimes they fix them, and sometimes they create new problems. But even if they fix everything and it's perfect, don't worry. The folks who are in charge of finding problems will find new problems to solve. So it's a give and a take. It's two sides of the same coin. We have the problem formulators, the problem discoverers, people who say, hey, this is a problem, we need to solve it. And of course, go ahead and stick any human problem you want. Overpopulation. Right now we have a COVID problem. We have a social distancing problem. We're using too much energy problem. We have an air pollution problem. We have a global warming problem. We have all these problems. They're handed over to the scientists, and the scientists figure things out. So both are needed. We need balance in the force, if you will. So what if you can do both? What if you are a single person and you know that there are times to look at a situation and find out what the problem is and define the problem? And then you know that now that we know what the problem is, I'm going to put away my problem finding glasses, and I'm going to put on my problem solving glasses. That's what we call innovators. This is where innovation happens. And I didn't grab the ISBIT logo, but of course that's where we think ISBIT is. Because ISBIT spends so much time in the arts defining problems and in the sciences solving problems, we like to think that one human being can do both. Typically, this might be the idea of a research and development, but usually we'd have a person who only works for research and only works for development. But in this case, we're going to be talking about those humans that are in this sociocultural open system, that they can be innovators, and they can use both sides of their brain, and they can use both sides of their multidimensionality often enough so that they can go ahead and realize it's time to find out what the problem is, and now it's time to solve the problem, which is pretty, actually kind of pretty cool.